Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 417 Pacific Atlantic Water Flow. This is a medium level graph problem, and we're told that we've got an M by N rectangular island that borders both the Pacific Ocean and Atlantic Ocean. And the Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. So Pacific Ocean touches the top and left, and the Atlantic Ocean does the bottom and right edges. And we're told that the island receives a lot of rain, and the rainwater can flow to neighbouring cells directly north, south, east, and west if the neighbouring cell's height is less than or equal to the current cell's height. And water can flow from any cell adjacent to an ocean into the ocean. And we basically need to return a 2D list of grid coordinates which denote that the rainwater can flow from that cell to both the Pacific and Atlantic Oceans, obviously making sure that the neighbouring cells are less than or equal to the current cell's height. So just to kind of explain this a little better, if we look at this cell here, cell 5, well, cell 5, rain can flow from cell 5 to the Atlantic Ocean because the cells 1 and 1 are both less than or equal to each other. And it can also flow to the Pacific Ocean because 4 is less than 5 and 2 is less than 4. And we can also do this top as well as from right. So all 4 adjacent sides from 5 send water to the Atlantic and Pacific Ocean. And this would be in our result output because it satisfies a condition of rainwater being able to go to the Pacific Ocean and the Atlantic Ocean. So how can we solve this problem? Well, the way we can solve this problem, we can use a depth first search function, so we can go to each cell and then look at if it can go to the Atlantic Ocean and the Pacific Ocean. But as you can imagine, it would be quite complex. It wouldn't be quite complex to write, but it would be very resource intensive, and it would take unnecessary resources to run, and it wouldn't be the most optimal solution because we'd have to do depth first search for every single cell in our matrix or in our grid. So the alternative is to use a more optimal breadth first search approach, and this will allow us to have a better performance, but also it's more optimal in being able to understand it. So to do this breadth first search approach, we're going to have 2 queues, a Pacific Ocean queue and an Atlantic Ocean queue. And instead of starting from the center cells and going down to the ocean, we're going to start from the ocean. So we're going to start from the ocean and find all adjacent cells where water can flow into the island. So in this example, we'll start off with the Atlantic Ocean, the Pacific Ocean. So all these cells neighbor the Pacific Ocean, and it's these cells over here that can that water can come into the island from. And we can do the same for the Pacific Ocean. So we can say all these cells neighbor the Atlantic Ocean, and as we move into the island, we'll come across cells where we overlap both the matrices of our Atlantic and Pacific Ocean. So both of the queues are going to have the coordinates of our Pacific Ocean and Atlantic Ocean. So we know that all these cells which neighbor or let water flow from the Atlantic and Pacific Oceans are going to be in our result. So that's kind of the general theory behind our solution. We're basically going to have 2 queues, one for Pacific Ocean, one for Atlantic Ocean, do a breadth first search, and then do some processing afterwards to check for each of our row rank coordinates, which one exists in both our sets or in both our output hash sets. So let's hop straight into the code. We're going to be writing this up in JavaScript, and the first thing we want to do is get the number of rows and the number of columns. So I'm going to say rows equals height.length, and columns is going to be equal to height 0.length. And we want to create a Pacific queue, and we also want to create an Atlantic queue. And we want to say, let's iterate through our entire grid and push the initial state for both of our queues. So for breadth first search, we need to push in the initial cells which neighbor either of our oceans. So let r equal to 0, r is less than rows, r plus plus. And I'm going to actually copy this as well, so I don't have to write it again for columns. C is less than columns, C plus plus. Okay, and now I can say if our row is equal to 0 or our column index is equal to 0, or our column is equal to 0, well, we know that we're probably neighboring the Pacific Ocean. So this is going to be the top or the leftmost column. So the top row or the leftmost column, and we can push to the Pacific queue our coordinates. So we're going to push the row and column. Otherwise, we can push to our Atlantic queue if the row is equal to rows minus 1, so the bottom row, or the right-handmost column. So if C is equal to cols minus 1, and that'll be our two queues built. And now we need to actually do BFS, so perform BFS. So let's create our breadth first search function, and our breadth first search function only needs one thing. It only needs our queue. So we're only going to pass in either our Pacific queue or our Atlantic queue. And we want to create a hash set, and this hash set is going to be what we use later on to check if our rows and columns are in either our Pacific or Atlantic hash sets. We also want directions for our breadth first search, so it's going to be top, bottom, right, and left. And we can say while our queue is not a 0, so it's not an empty queue, let's pop from our queue. So we're going to say queue.shift, if I can spell correctly. And we want to set in our hash set the current row and column, our current coordinate, so the row and column that we've just got, to true. So we're going to set this equal to true. And we want to say for all the adjacent cells, so for all the directions, so for each direction of directions, let's create our new row and our new column. So our new row is going to be equal to the row and our direction 0, and the new column is going to be equal to C and direction 1. And we're going to say, first we're going to check if these two new coordinates, if these new coordinates are out of bounds, or we've already seen them in our visited set, in our visitor hash set. We're going to say if our new row is less than 0, or new column is less than 0, or new row is greater than or equal to rows, or new column is greater than or equal to cols, or visited RC is equal to true. Well, we could just do visited RC. We can say continue. So we're just going to skip this cell because it's either out of bounds or we've already visited before. The next thing we want to do is actually check for our height. So this requires a bit of explanation. So we're told previously that the neighboring cells should be less than or equal to the current cell's height. So for example, 5, the cells that go out towards the ocean are less than or equal to the neighboring cell's heights. But we're starting from the ocean itself. So we want to make sure that the heights are greater than or equal to the previous cells in our path. So let's do that. Let's say if height and passing our new row and our new column is greater than or equal to heights RC, we can push to our queue the new row and the new column. And once our while loop is finished, we can return our visited hash set. So that's our depth first search function written. And now we can actually get the hash sets for both our Pacific Ocean and Atlantic Ocean. So BFS Pacific Q Atlantic equals depth first search Atlantic. And then let's create our result variable, our result array. So now we're going to iterate through our entire grid, and we're going to say if Pacific, so basically if our rows and columns are in both our Pacific and Atlantic hash sets. So if R, and to be honest, I could have probably done this a more cleaner way using a set, but I thought when I was writing this at the time that it would be simpler with a hash set or with JavaScript objects, which in hindsight probably wasn't the best idea, but it still works. It's just not as clean as with a set. And then we want to push the row and column to our result. So push the row and column, and then return our result once we're finished. So let's submit our code. Breadth first search Pacific Q. I think I have got typos here. They should just be abbreviations. We get the wrong answer. So let's have a look actually why we're getting the wrong answer. I wonder if it's something over here. Okay, so it looks like it's the fact that we're checking, instead of checking our new row and column, we're checking our current row and column, which is just not what we should be checking. So let's submit our code again. This should be the only bug in our solution, and it is. We pass all other test cases. So in terms of time complexity, this is an O of m by n time complexity and big O of m by n space complexity, where m and n are the number of rows and columns in our grid. With that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.